Okay, doing number 32 here. This one is a little bit not intuitive, meaning you look at it and you're like, I have no idea what to do. You had to recall a rule you learned back in Algebra 2 probably, sum of cubes. Okay, so to approach this problem, I got to come up with a way to break this apart. And you think I can factor something, and you're like, no, I can't. It's not an identity. It's not squared. I can't do anything with it. This is a tough one. Okay, I wrote down the rule, and we'll just break it apart nicely. You're more familiar with this written as like maybe, oh, I don't know, 27 plus x cubed, and break it apart. But this time we just have trig functions. Is not any different at all. We just have to think about it. Okay, so let's let that equal, let's say sine of x equals a, and let's say cosine of x equals b, and we're just going to do it very straightforward. Okay, so why don't we say sine of x plus cosine of x, and again we just did that right there. Now, following the rule, a squared. Well, if we let that a, we're going to say sine squared of x minus ab. We're going to say sine of x cosine of x. Okay, and we're going to say plus, and we're going to say cosine squared of x. Okay, that is not bad at all. Now I'm looking at that for a second, I'm like, wait a minute. Sine squared of x plus cosine, isn't that 1? Isn't that your Pythagorean identity? So I think we can say sine of x plus cosine of x. This and this give me 1. Isn't that 1 minus sine of x, cosine of x? And I say, wait a minute, isn't that denominator 1 minus sine of x? I don't really have to keep going with this, I guess, because I think you see it. That is the answer. Done. Good job.